Back to the next exciting rendition of Honors Calculus via Mr. Chivers. Here we go. Okay, so this is yet again another set of notes. I wish I was there because this is kind of important stuff. But today is 2.1, Power Rule of Derivatives, and your homework is attached. So I set this up so that it's kind of goes in a good order for you to do by yourself. I really think you could figure all this out by yourself. So I really want you to try to do as much as you can before you listen to what I say. Okay, so I would pause right now, try to do as much as you can, and then you can check your work out from there. Okay, pause now. Okay. So as we learned, the derivative f prime of x of a position function f of x is the velocity function. It tells us the instantaneous rate of change at any point on the position function, which can be depicted as the slope of the tangent line through that point. Okay, so with this in mind, let's explore some ideas on how to find derivatives more efficiently. Okay, so we're going to start with some constant functions. So this is the function f of x equals 2 right here. What is the slope of the tangent line at any point? So if I drew the tangent line here, it would just be the flat line. If I drew it there, it'd be the flat line, so on and so forth. What is the instantaneous rate of change? Well, it's just the slope of the line, and the slope of the line there is 0. Okay? So looking at this problem, the slope of the line is 0. So f prime of x, f of x being 2, the derivative of 2, or the velocity function, would be 0. Okay? What about g of x equals -4? That's this line down here. What is the slope of the tangent line at any point there? Well, the slope of the line is 0, so that means the slope of the tangent line is 0. Okay, so g prime of x would be 0 as well. So if I take the derivative of this, I get 0. If I take the derivative of that, I get 0. So in general, what is the derivative of any constant function? If f of x equals any number, then f prime of x is always 0. Okay, that should make sense because it's always going to be a horizontal line, and the slope of the line is always going to be 0. Okay. Now, what if I have a linear function? Okay, so this is the function h of x equals 3x plus 2. What is the slope of the tangent line at any point? So if I were to draw a tangent line on any point here, I'd end up just overlapping the line that's already there. So what's the slope of that line? The slope of that line is just 3. Okay, so whatever the slope of mx plus b is. Okay, so here I get 3. So h prime of x here, if I take the derivative, no matter where I go, it's going to be the same. So h prime of x is 3. Okay, what about -1/2 x? Okay, so -1/2 x looks like this. The slope of the tangent line at any point, again, it's just going to be the slope of the line. That gives me -1/2. Okay, so the derivative of f is going to give me -1/2. Okay, so the derivative of 3x plus 2 is 3. The derivative of -1/2 x is -1/2. In general, what is the derivative of any linear function? Okay, so if f of x equals ax plus b, f prime of x is just going to be the slope, whatever that a value is. Okay, so again, that should make sense. Whatever the slope of the line is, that's the instantaneous rate of change. Okay, it's going to stay the same. All right, so for constant functions, it's pretty simple. For linear functions, it's pretty simple. We don't really need a rule there. It just should make sense. But for higher degree polynomials, it's a little bit harder. Okay, the slopes are always going to be different at different points. It's not linear. So we'll try to figure this out algebraically. Okay. So we used to find the derivative with this definition, okay, but this is rather tedious. It takes quite a while to do, and it's not always possible given certain polynomials and functions. So the big question, is there a way to find the derivative more efficiently? Okay, so I gave you some examples here. F of x is x to the 7th. The derivative is 7x to the 6th. How do I go from there to there? Okay. F of x is 4x to the 3rd. The derivative is 12x squared. How do I go from there to there? Okay, so for all these examples, try to look at my position function and the derivative and try to find how it gets there. Okay, there's a rule that makes this, and makes that, There's a rule that makes that, and that, and that, and that. and so on and so forth. Okay. So, in general, what is the derivative? What is the derivative of term with a real exponent of any term? That's what I meant to say. What is the derivative of any term with a real exponent? Okay. So let's see if you figured this out. Drum roll, please. If f of x equals ax to the n, f prime of x is, give me my pen here, n times ax to the n minus 1 power. Okay, so whatever that exponent is, I'm bringing that down and multiplying it first by whatever that coefficient is, and then I'm subtracting 1 from the exponent. Okay, so the first thing, again, I do is bring it down and multiply, and then I subtract the exponent by 1. Okay, so just to kind of take a peek. X to the 7th, the coefficient is 1. I bring the 7 down and multiply, so that gives me a 7 as a coefficient, and then I subtract the exponent by 1, so it's to the 6th. Down here, I'm just going to split it up, okay? So the derivative of that and the derivative of that. So 4 times 2 is 8, and then I subtract 1 from the exponent, so it's to the 3rd power. 2 times 3 is 6. I subtract 1 to the exponent, and that gives me a 1. Okay, and this should work for any term of any real number exponent. Okay, so the square root of x is the same thing as x to the 1/2. So if I have any roots, I should write it in exponent form. And then if I follow my rules, I bring the 1/2 down. Okay, so 1/2 x, and then I subtract 1 to the exponent. So this would give me, oops, I did that one wrong. So this is a positive right there. My apologies. Positive 1/2. Okay, so if I do this correctly, I get 1/2 x to the negative 1/2 because I'm subtracting 1 to the exponent. Then I move that down, and it becomes 1/2 x to the positive 1/2 here. Okay. If I have any fractions, I should make it a normal term. So I don't want any division. I want to move that up to be all on the same level. So 1/x squared is the same thing as x to the negative 2. So then if I follow my rules, I bring the negative 2 down, multiply, and then subtract by 1. So negative 2x to the negative 3rd, which I can rewrite as negative 2/x to the 3rd. Okay, so any term with a real exponent, I can follow my power rule. Okay, and this is where most people get mad, because then they're like, why did we do this so many times? It was such a waste of time. It's kind of important to kind of understand where the derivative comes from. If we just went right to the product rule, a lot of people wouldn't really understand that it's kind of a complex idea to find a derivative in general, because we're finding the slope of the line. The slope requires 2 points. We want to find the slope at 1 point. So it's kind of understand to figure out kind of the process of going from 2 points to 1 point. And without doing that, we wouldn't kind of get it. Okay, so this is kind of a totally new deal. It's not just kind of come up randomly. There was a process in getting to this point. Okay. But just to kind of see how this changes things here, this is an exact question from the last quiz. So use the definition of the derivative to find the instantaneous rate of change for each of the following functions for the given x value. So here we used to do f of x plus h plus f of x all over h, and then do the limit and yada yada yada. Now I can just do the power rule. Okay, so f prime of x, the derivative of x squared is just 2x. The derivative of negative 3x is minus 3. And then the derivative of 5 is 0. That's a constant term. So now I can find my derivative really quickly. And then I punch in my x value. So f prime of 4 is equal to 2 times 4 minus 3, which gives me 5. Okay, so it's much more efficient now, obviously, and it's a little bit more direct. Okay, these are going to get more complicated. Okay, so we have a power rule if it's like a polynomial type looking function. But if there's any other operations or compositions or anything, we have the product rule, we have the quotient rule, we have the chain rule. So it does get more complicated than this, but the power rule is one of the big rules. Okay. So just kind of make sure we understand this idea. So given this function, find the derivative of f of x using the power rule. So again, hopefully you did this already. But if you didn't, pause it now so you can give this a shot. So if I follow my power rule, I should get f prime of x equals negative 2x plus 2. Okay, bring the exponent down and subtract. And then the derivative of any linear term is just the coefficient. Okay. The derivative of x equals 2. So if I do f prime of 2, I get negative 2 times 2 plus 2. So that gives me negative 4 plus 2, which is negative 2. What is the derivative at negative 1? I can find that as well. So f of negative 1 gives me negative 2 times negative 1 plus 2, which gives me 4. Write the equation of the tangent line through x equals negative 1 and draw it on the graph. Okay, so I need to find, this should be a prime right there. So I need to find my function value at negative 1. So if I plug in negative 1, I get 1, but a negative. And then plus a negative 2, which gives me a negative 3. So my equation would be y plus 3 equals my slope, which is 4, times x plus 1. So I should get a line from that point with a slope of 4. So about right there. Okay. Right through that point. Okay, so the line should look a little bit something like that. Okay. So where's the derivative 0? We're going to do a bunch of this in the future. The derivative is 0 where it's neither increasing nor decreasing. So just looking at the graph, that would be at a max or a min point. So it looks like it's at x equals 1. How do I confirm that using the equation? Okay, so if I want my derivative to be 0, the derivative is f prime of x. I'm going to set that equal to 0 and solve. So 0 equals negative 2x plus 2. I subtract 2, and then I end up getting x equals 1. Okay, so this is the process of finding positions of max and mins. The max and mins are where the derivative is 0. It's neither increasing nor decreasing. So in the past, you always had to use a graphing calculator to find a max or a min. Now that we know how to find derivatives, we can just set the derivative equal to 0 and solve. Okay, so we're going to do a bunch of that in the future as well. Okay, so this is kind of what the derivative helps us do. And now that we have a better understanding of that, let's just practice finding some derivatives. Okay, so these are just some general rules. Again, these are the notations. We talked about these before. F prime of x, y prime, dy dx, d dx of f of x. So d dx itself is kind of the notation for derivatives. So we're taking the derivative of f of x and so on and so forth. So we talked about this one. The derivative of any constant is 0. The derivative of x is 1. So any linear equation is just the coefficient. So in this case, it's 1. The derivative of a constant times a function is, so here if we take the constant out, basically, the constant can be taken out of the derivative, and then we can find the derivative of f itself. Okay, so for example, if I'm finding the derivative of like 7x squared, I can really do 7 times the derivative of x squared. The derivative of x squared is 2x, and that gives me 14x. Okay, so I don't really need to do this. I can just bring that down, multiply, and subtract. This is really more, once we get to more complicated functions, this rule becomes more handy, where I can't just multiply this out. But that's kind of what this property is saying. Okay, and then this property is kind of what we've been talking about before as well. So if I'm finding the derivative of like 2x squared minus x, I can just kind of split these terms up and find the derivative individually. So I can do d dx of 2x squared minus d dx of x. Okay, so if there's more than one term added or subtracted, I can just split it up and find the derivatives separately. Okay. So looking at these, let's see if we get the gist. Okay. So find the derivative of each. If not in standard form, polynomial form, simplify it first, then derive. So this is already in standard form. There's no division of x's. Everything's to a real number power. So then I just follow my rule. So bring the 5 down and multiply, and then subtract by 1. So that gives me y prime equals 10 over 3 x to the 4th. And then bring that down, multiply, subtract by 1, 3x squared. Okay, so that's that one. This one's not in standard polynomial form. Okay, so I want everything on the same line. So I should rewrite this as x to the 4th minus 5x to the negative 2nd. Now there's no division of x's, and now I can follow my rules. So y equals 4x to the 3rd, following that derivative rule. And then bring the negative 2 down, so that's a positive 10, and then subtract by 1, so x to the negative 3rd. And you can really keep it like this if you want, or you could flip it down. So y prime equals 4x to the 3rd plus 10 over x to the 3rd. Okay, so either one of these is fine. Okay. So if we have a fraction, we make the exponent negative to do the power rule. If we have a radical, we should make that into an exponent as well. So I should rewrite this. Y equals negative 5, and then the 5th root of x squared is really x to the 2/5. And then I have a minus 4, and then I have a minus 3x to the negative 4th. So now everything's on the same line. Everything's to a real number power. So then I follow my rules. Y prime equals, multiply negative 5 by 2/5, so that should give me negative 2. And then subtract 1 from 2/5, so that's x to the negative 3/5. The derivative of any constant is 0, so that one's just gone. Bam. And then negative 4 times negative 3 is a positive 12, x to the negative 5th. So again, you could keep it like this, or you can simplify. So y prime is negative 2 over, you could do x to the positive 3/5, or you could do the 5th root of x to the 3rd. All of these are the same idea. And then plus 12 over x to the 5th. And that would be your final answer, either one of those two forms. Okay. And now from here, we could do a separate rule. So this is a quotient. We're dividing these. So I could use the quotient rule here, but I could also simplify this. So both of these are being divided by x. So I can rewrite this as f of x equals 5 over x plus 1. And then 5 over x is the same thing as 5x to the negative 1st plus 1. So now if I derive that, that would give me negative 5x to the negative 2nd, and then that's gone. Okay, so this would give me negative 5 over x squared. Okay. So with that idea, again, I want it to be a normal polynomial form, just adding or subtracting terms. So for this one, I should multiply it out. So f of x, FOIL it, that gives me 6x squared, plus 8 minus 9, so that's minus x, and then minus 12, and then you can derive it from there. And then for this one, just to kind of make sure, so the 5 is part of the denominator, but 1 over 5 itself is technically the coefficient. So I would rewrite this one as y equals 1/5, x to the negative 3rd, and then minus 1/2, x to the negative 4th, and then you can derive from there. Okay? All right. So hopefully that makes sense. I did a lot of talking there. So give it your best shot. This is your classwork/homework right here. Feel free to work together. And yeah, all right, have fun. Peace.